During the Cold War, everybody was talking about the space race, right? The moon, the stars. But there was another race going on, one that was way less public, but maybe even more ambitious. It was a journey not up, but down. This is the story of that race, a journey to the center of the Earth.
I mean, think about it. It's a question we've been asking for centuries. We've mapped the deepest oceans, we've sent probes to other planets, but the world right under our own feet? That's still one of the last great frontiers. What is really down there in all that heat and pressure?
Well, back in the 1970s, the Soviet Union decided they were going to be the ones to find out. This facility you're looking at, way out on the remote Kola Peninsula in Russia, this was their moonshot. It was the starting line for the wildest drilling project in human history, the Kola Superdeep Borehole.
And let's be real, this wasn't just about pure science. Nope, this was a Cold War showdown, a high-stakes race to see who could punch a hole deeper into our own planet than anyone had ever dared. This thing was a marathon, not a sprint. The whole project took decades. They actually started drilling on Lenin's 100th birthday in 1970. By 79, they'd already blown past the American depth record. But they didn't stop. They just kept pushing, right into the early 90s, testing the absolute limits of their technology. And their ultimate goal? It was absolutely mind-blowing. They wanted to drill 15 kilometers straight down. That's over 9 miles. The plan was to go right through the Earth's crust and pull up a physical piece of the mantle for the very first time. In some ways, that's a tougher engineering challenge than even getting to the moon.
So what did they think they were going to find down there? I mean, they weren't just drilling blind. They had a map, a kind of blueprint based on all the best science available at the time. And that map was made using a technique called seismic reflection. It's actually pretty cool. Geologists basically send powerful sound waves down into the ground, and then they listen for the echoes that bounce back. It works just like a medical ultrasound, but for the entire planet. So this right here, this is the actual seismic data they were looking at before they even broke ground. Scientists saw these really strong, clear lines. They call them reflectors. And the interpretation seemed obvious. These had to be the boundaries where one type of rock stopped and a totally different one began. And based on that seismic map, the scientific community was pretty much unanimous. The plan was simple. They'd drill through solid, totally dry granite, then, somewhere around 7 kilometers down, boom, they were sure they'd hit this huge boundary, and the rock would change to a much denser type called basalt. This wasn't a guess. This was the textbook model of the Earth's crust. But as that drill bit chewed its way deeper and deeper into the planet, the rock samples it sent back to the surface, well, they started to tell a very, very different story, a much more shocking story. First, let's just appreciate the sheer scale of this. The drill finally bottomed out at 12,262 meters. That's more than 7.6 miles deep. It is still the deepest artificial point on the entire planet, a record that's held for more than 30 years. But here's the problem. At that depth, the heat was just unbelievable. It hit 220 degrees Celsius. That's 428 Fahrenheit. That was way hotter than any of their models predicted. And in the end, that intense heat is what stopped them cold. The equipment just couldn't take it anymore. And here it is, the first massive scientific bombshell. You remember that super clear textbook boundary they were 100% sure they'd find at 7 kilometers? The spot where granite was supposed to turn into basalt? It wasn't there. It just never appeared. They drilled past 7 kilometers, then 8, then 9, all the way to 12, and it was granite the entire way. The geological map of our world was just plain wrong. So let's just lay it out side by side. The prediction was solid, dry rock. The discovery, rock that was cracked and fractured, and completely soaked with water. Everybody thought that was impossible down there. The rock type, granite, didn't change, but its actual physical properties were nothing like they expected. The Earth was hiding a huge secret. Okay, so this discovery created a brand new mystery. If that boundary wasn't a change in rock type, then what in the world were those strong echoes the seismographs picked up? What had they actually been seeing all along? So they went back to that original seismic data, but this time they had physical proof from the borehole, and suddenly it all made sense. Those strong lines, those reflectors, they weren't rock boundaries. They were the seismic echoes of massive, water-filled cracks deep inside the granite. A scientific paper from 1998 just put it out there in plain language. The sound waves were slowing down and bouncing off of cracks and fractures filled with fluid. They weren't hearing a change in rock, they were hearing the sound of water, miles and miles underground. And this realization gave us a completely new picture of our planet. The deep continental crust, which everyone had always thought was this solid, unbreakable shield, could actually be, well, porous and wet, almost like a giant rocky sponge in some places. This discovery fundamentally changed how we understand the ground we live on. Now, the project eventually had to be shut down. The heat was just too much, and after the Soviet Union fell, the funding dried up. But the scientific knowledge it gave us, that's forever. You know, these two pictures really tell the whole story, don't they? On the left, you've got this cutting-edge science facility, the absolute peak of ambition. And on the right, that's the same place today. It's all in ruins. And the borehole itself, the deepest hole in the world, is just sealed shut under a rusty metal cap. So what's the big takeaway from all this? The Kola Superdeep Borehole literally rewrote geology textbooks. It proved that huge amounts of water can exist deep within the crust. It showed us that our remote sensing methods, as cool as they are, can be totally misleading without ground truth. But most importantly, it taught us that the earth beneath our feet is just so much more complex and dynamic than we ever gave it credit for. The Kola borehole might be sealed forever, but that human drive to explore, to find out what's underneath us, oh yeah, that is very much alive and well. Today, the torch has been passed to incredible vessels like the Japanese drilling ship Chikyu. It's basically the spiritual successor to Kola. As part of a huge international effort, it's drilling into the seafloor, pulling up core samples, and continuing that grand project of understanding our own planet. You know, the story of the Kola Superdeep Borehole is the ultimate proof that sometimes even our most cherished scientific theories can be completely shattered by one direct look. It really makes you wonder, doesn't it? What other rock-solid facts about our world are just waiting for the right drill bit to come along and prove them wrong?